So first of all, I would just like to welcome you to this presentation. So in this presentation, we will be discussing or talking a bit about inherently safer design. We will be talking more about the strategies of inherently safer designs. But before going deep into this topic of inherently safer design, let us try to find out what actually did happen in the year 2008. So on August 28, 2008, a powerful explosion took place, and this explosion took place at a bare crop science plant in the Institute, West Virginia, just outside of Charleston, that is the state capital. So, in this explosion that has taken place in West Virginia, in the Bears plant, two persons were killed and eight others were injured because of this incident or this explosion. So, after this explosion that has taken place, a chemical safety board investigation committee was held to investigate the explosion, how it has taken place. After the investigation, it is found out that the explosion has resulted from a runaway chemical reaction that was going on inside a process vessel. But now the most interesting thing that came out from this investigation is that if the exploding vessel or the pieces of the exploding vessel would have taken a different trajectory, then pieces of those exploding vessels could have hit nearby pipings, potentially causing a release of highly toxic methyl isocyanate gas. The same dangerous chemical that killed thousands of people in Bhopal in the year 1984. So we all do know about the Bhopal gas tragedy, which took place on December 3, 1984, in which a large amount of people were getting affected because of Bhopal gas tragedy, affected a total population of around 520,000. It is a really heavy number. Now, talking about the incident that took place in Bears plant, this incident might have gone, to an extent where this incident might have also turned out to be a tragedy, just like Bhopal gas tragedy. It did go lucky to not have encountered that tragedy in the year 2008, but it as well would have gone wrong. But now, from this incident, there arises a question to whether or not we have an inherent safer alternative to storing and using of different harmful chemicals or toxic chemicals. To this question, the answer is yes, we do have some inherent safer design or strategies that can be taken in consideration. Now, as we have been introduced with this term inherently safer design, what do we actually mean by inherently safer design? So inherently safer design are the strategies which aim at avoiding the hazard, so that the hazard doesn't even take place at the first place. This particular strategy does not aim at controlling the hazard once it has taken place. It's more about avoiding the same hazard before it is even taking place. It is more like preventing the hazard, not trying to curing the hazard after it did took place. And it is due to these strategies, it helps us to reduce the amount of hazardous material and the number of hazardous operation in the plant, in different chemical process industries or in different chemical plant. Now let us try to find out why are these inherent safer designs so important to us. What are the importance of inherent safer designs? Now let us try to take the examples of those toxic chemicals. There are lots of toxic chemicals which we cannot eliminate or we cannot reduce the use of those chemicals in the chemical process industries. It is because of this, the probable hazard that can take place because of these chemicals or the use of those chemicals in the process industries cannot be totally eliminated, or it cannot be reduced to insignificance. but it can only be managed throughout the lifetime of the facility. And thus we have to take, in this context, we have to take the help of inherent safer designs to inherit the strategies that has been put forward by inherent safer designs in order to avoid process incident that can result in lot of big losses and harms to different peoples, or uh, to lots of peoples, which we have also seen in the case Bhopal gas tragedy. Now, talking about the inherent safer design strategies, we have four major strategies that we can take in consideration. The first one is to minimize the use of harmful chemicals. Second is to substitute the use of more harmful chemicals into less harmful chemicals in case if we have got some substitutions. Is to moderate the use of those harmful chemicals and to simplify. To minimize is to reduce the amount of hazardous material present at any one time. It is to reduce the amount of potential energy present. Our aim is to get the system closer to a zero level potential energy, thus reducing the potential impact if containment or control of the hazard is lost. Uh, Talking about the strategies for making a process inherently safer for minimization, there are processes like strategies like inventory reduction, for example, is the use of fewer tanks, just in-time delivery, is to lessen the vapor volume, is to generate a demand, is to receive by pipeline instead of by large trucks or rails. There are also strategies like process intensification, where a chemical and process design approach that leads to substantially small, cleaner, safer, and more energy efficient process technologies. The next strategy of inherent safer design is to substitute. And what do we actually mean by substitute? To substitute is to replace with a less hazardous material or condition. Is to substitute the more harmful materials or harmful chemicals into less harmful chemicals. For example, cleaning with water and detergent rather than using flammable solvents. So we can replaces the flammable solvents with water and detergent. So this can be one example of substitution that we can take place, or that we can uh, take the help of. Let us try to find out some strategies for making a process inherently safer for substitution. Is the commercially available alternatives, is to use or inherit the commercially available alternatives, is to use the alternative raw material or intermediate that can be transported and stored more safely, is to use alternative chemistry like biosynthesis routes and various other such processes. Talking about the alternatives that we can find in case of chlorine, there are substitutes just like sodium hypochlorite, calcium hypochlorite, hydrogen peroxide, chlorine dioxide, bromine, etc. Talking about the next strategy, it is to moderate. To moderate is to handle a material under less hazardous process condition. Is, in other words, it is to reduce the strength of an effect. And talking about the strategies for making a process inherently safer by moderation or attenuations, the first one is to dilute, or is to take the help of dilution. For example, using aqueous instead of anhydrous form, or we can also lower concentration or use of lower concentrations in case of higher concentrations, or we can substitute lower concentration in case if it is possible without going for higher concentrations. For example, lower concentration of benzoyl peroxide paste using in solutions such that the solute would boil off before a runaway, or mixing coal dust with rock dust. We can also take the help of refrigeration. For example, storing anhydrous ammonia as a refrigerated liquid instead of as a liquefied gas. So we can store ammonia, anhydrous ammonia, as refrigerated liquid instead of using as a liquefied gas. The last strategy of inherent safer design is to simplify. So what do we actually mean by simplify? To simplifying is to eliminate unnecessary complexity, is to eliminate problems by design rather than adding equipment or features to deal with them. Some simplifications or strategies of simplifying are use of simpler equipment arrangement. For example, gravity flow or natural convection is to eliminate interconnections to reduce the likelihood of inadvertent mixing, is to minimize number of flanks, connection, and other potential leak condition. So with the help of these strategies, we can minimize the loss while using those harmful toxic chemicals which cannot be eliminated or reduced to insignificance in different process industries. So with this, I come to the end of my presentation. I hope you have got a little idea about what I have discussed. Thank you so much.